Good afternoon, everybody, and thank you for joining me. My name's Daniel, and I'm one of the UK sales engineers for Zeisel UK. So I primarily look after the North. So thank you all for joining me today on this webinar. So today we're going to be looking into one of the new generation of access points. So this is the 802.11 AX standard, which is also referred to as Wi-Fi 6. So first I'm just going to go through the actual product portfolio as we see it today. So we've got one available currently into the channel, which you can order from distribution. That is the WAX650S. That is a 4x4 11AX antenna, both for 5 gigahertz and 2.4 gigahertz. The good thing is about these access points is it's all about increasing density and throughput, and you will notice that actually on this access point they do have a 5 gigabit Ethernet port, and they also have a 1 gigabit pass-through port as well. And it is key to note as well that they require the .BT standard, so the Ultra PoE. All of the access points are going to be Nebula Flex enabled straight away, so you will be able to onboard them onto our Nebula portfolio. If you don't know what Nebula is, there are some previous webinars which have been recorded and are available on our website. They will show you what Nebula is and the specific feature set that it offers. You will see that we've got other access points which are going to become available. There might be slight delays to the dates on here due to obviously logistical issues worldwide. So we've got the WAX510, that's a 2x2 antenna, both on the 5 gigahertz and the 2.4 gigahertz, and you'll notice that this only has a 1 gigabit port with it, and it doesn't require the .BT standard. So there are different flavors of the access point. So if you are looking to implement them into a project, make sure obviously you know the full specification that you're looking for. The guys at distribution or at Zeisel will be more than happy to point you in the right direction. We've got our NWA 1123 AX, which is going to be coming out, and we've also got the AX Plus. Again, they will be available on Nebula Flex. The NWA 1123 AX has a 1 gig port on it, whereas the AX Plus actually has a multi-gig port, which is 2.5 gigabit Ethernet. I will show you the switches which are supported in multi-gig, and I'll explain that a little bit more later on as well. The WAX610D, so that's again got a 2.5 gigabit Ethernet port on it, and that's a 4x4 antenna. So that means it's got 4 receive radios and 4 transmission radios. And it's also got a dual optimized antenna as well. So one of the good things is about the actual device itself, they are really built to last and built to reduce interference and provide the best quality wireless that ultimately you can get. So it does have a 4 and 5G filter on it. It's got a heat spreading system in there as well to help disperse the heat so the unit doesn't overheat and get hot. It's got the smart antenna technology, which is quite good because the way it actually functions, it allows for high density environments and doesn't hinder modulation if you've got people with poor connections and things like that. The smart antenna technology I can go into in a bit more detail if it's just something that you're interested in, and we do have again webinars which do explain this in a lot more detail. It also supports the Bluetooth beacon as well, so you can hook into like a third party using an API, and it will allow you to get analytics as well as push notifications to people that are in the vicinity with Bluetooth enabled. So this is aimed towards like retail space. So if someone's outside of a shop, it can actually push potentially offers that you've got going on, and ultimately generate interest to bring them into the retail establishment. So why is 802.11 AX needed? So Wi-Fi does have its limitations. It's always going to have its limitations over a cabled backbone network. So currently, you've only got the ability to transmit to a single device per channel. So this is due to its collision avoidance and back-offs and duration values. And ultimately, once you've got a connection which has a poor modulation, it will actually affect everybody else on there as well. It's like a timing mechanism. So it'll feed one client and then feed another client with information. And the worse the signal would mean that they're further away, which means the information takes longer to get to them. Ultimately, then everyone gets queued up. So there's a limited number of channels. So certainly in the 2.4 gigahertz, which is why 5 gigahertz was brought out. 5 gigahertz is also getting quite congested because of, as technology evolves, people are getting more devices. You've got Internet of Things. I mean, you've got cars now which have built-in wireless so that they can update their firmware for all the electronical elements in the car as well. So the more devices we introduce, the harder it is to be able to maintain a good level of connection. So we need to obviously think, what are we going to do to resolve this? So network density and bandwidth requirements are increasing. So as I've touched on, as technology increases, all these devices are coming out. You've got smartwatches, you've got cars, you've got all these Alexa devices and all this smart home equipment. And as they increase, there are more devices connected onto it. The bandwidths are increasing because of like 4K streaming and things like that. So we have to adapt to that. We have to be able to provide a good level of Wi-Fi to maintain these connections. So congestion is getting greater. So people are putting in more access points. You're getting councils and places like that are also implementing like town-wide Wi-Fi as well, which again, that could be populated throughout, and it will interfere with obviously yours, which is inside as well. So we obviously need to think of how we're going to combat them sort of situations as well. The 802.11 protocol overhead and inefficiency. So the actual protocol itself has a lot of overhead just to make things function, and this creates a really inefficient way of working. And currently, we do have a few workarounds and being able to use some of the spectrums. However, there are certain spectrums we can't use, and there's constant debates in the US and Europe as to what spectrums we can use, what we can't use. So we need to come up with more innovative ways to combat this. So what does the 802.11ax bring, and how does it work? So 10 gig Wi-Fi. So theoretically, it will provide you a 9.6 gigabit wireless connection. As you can imagine, at the moment, it's nowhere near that. So that's massively improving the wireless connectivity that we know today. So technically, it's 4 times higher in capacity, coverage, and performance. So with the 8x8 APs and the multi-MIMO, it means that you'd be able to increase the actual access points depending on the applications and the devices you use. So there's more capacity there for your device to be able to use, which means it's not going to hinder any potential issues as you're starting to add more devices and increase the throughput. It's going to be able to maintain a good level of that. Dual band. So yes, the AX access point is going to utilize both the 2.4 gigahertz and the 5 gigahertz bands. And while many people have said that the 2.4 gigahertz band is too congested and it really has no future, AX and the technology behind it from a chipset level brings more efficiency to the 2.4 gigahertz band, and it will help devices with lower power requirements such as the Internet of Things, and where we'll see density in the units without needing higher bandwidth as well. So if we break it down into what a few other things that it benefits from. So 8x8 antenna, so that'll be 8 receive and 8 transmission radios. It also benefits from OFDMA. Now OFDMA is like a 4G type of technology, and I'm going to go into this in a lot more detail in a minute so I can really show you and let you understand what it actually is. So the resource units scheduling. Again, this is something that will be covered during the OFDMA discussion in a second. It's going to allow you for high modulation rates, so being able to modulate at a higher rate, therefore improving your throughput. The BSS color. Now, this is quite an interesting feature because if you've got 2 access points that have got roaming set up, and you're sort of in the middle of it, once you've connected to the best unit, sometimes what you'll find is because the signals will fluctuate, you'll actually bounce from one access point to the other. So you'll actually experience dropouts. So with this color frame, what it does is it actually adds, it's like a color code into the actual connection between your device and the access point, meaning that you will only ever go to that access point as long as you're in a certain remit. So it means that you won't flitter from one to the other, therefore causing dropouts. And then we've also got the target wake up time as well, which is another important resource scheduling feature supported by the AX protocol. So it allows devices to negotiate when and how often they will wake up to send and receive data, and it increases the device's sleep time and ultimately improves battery life of the actual client devices. So traditionally speaking, so for the A standard, the N standard and the AC standard, previously we've been using OFDM. So as you can see, each color represents a user, so that's a specific device. Each user will be allocated a certain timing slot. And again, this goes down to the signal as well. If they're at a poor signal, because they've got a slot in which they're being provided the wireless information, everybody else has got to wait. So the worse the signal, the longer the information takes. Everybody who's queued up also hinders that same problem. And then what we have introduced is OFDMA. So what OFDMA does is it allows you to break up the channels and to be able to serve multiple clients at the same time. So as you can see, user 1 has got a slot which also goes into the next slot as well, but the next slot also is feeding user 2, user 3 and user 0, meaning that they don't have to wait as long to be able to get the information. Therefore, it speeds up the transmission of wireless data between the client and the access point. So it really does improve the effectiveness of the wireless connections for the clients, making sure that it's quick and that they get the information as and when they should do, rather than having to wait about for it. So to put this in a bit more of a graphical sort of vision, so on the left-hand side, you've obviously got a spacecraft being towed down a road. Now, if anybody's behind that spacecraft, they're going to have to wait for that to move off or move off the street. Whereas with OFDMA, it will actually allow you to run side by side, so it's like a bigger road. Therefore, you've got more space. You can go around it and ultimately get there quicker with your information. So it kind of breaks it up. So rather than a client using the full 20 megahertz channel, it will break up all the resource units into little 2 megahertz channels to make sure that they can get the same information. So it's just like having a motorway with more lanes on it, allowing more data to flow without being congested behind the spacecraft as such. So I hope that sort of helps you understand the difference between it. So if you sort of go back to the previous slide, the OFDM would be the spacecraft, and OFDMA is the multi-lane highway on the right-hand side. So what are the challenges of AX? So to really benefit from AX, the clients have to support it. So there are some phones now which are being generated with the AX chips. I think the Samsung S10 was the first one. And there are also chips that you can upgrade your laptops with. And moving forward, obviously laptop manufacturers, PC card manufacturers and things like that are also going to be providing you with the AX network adapters required to really benefit from it. Some more capacity, so being able to provide a better backbone network. So you're going to need, like, as I say, a multi-gig switch, which I'll go into soon, which will allow you to do 2.5 gigahertz and 5 gig on traditional Cat5e, Cat6 and Cat7 copper cable. So no need for having to run fiber about. If the infrastructure is already there, then you'll be able to utilize it just by upgrading the access point and introducing a multi-gig switch to the network. So because there's more radios, more CPU power is needed for the AX. So in order to be able to power the unit, you require the Ultra PoE standard. So there are a lot of switches on there which support the BT standard at the moment, but they might only have a gigabit port on it. So albeit you'll be able to power them, but you won't be able to benefit from the 2.5 gig network card or even the 5 gig. So again, understanding the project that you're going into and the correct specifications is key when you're doing an AX project. But again, both distribution as well as here at Zyzor, we're more than happy to help you spec that up, making sure that you get the best out of it. This is a really valid point. So some of you may have seen that AX access points have been out for probably a number of months, but it's important to understand the differences between the early release and the later releases. So there's a version 1 and a version 2 of the chipset, and the version 1 of the chipset doesn't have the OFDMA functionality. So this is what I go back to, being able to serve multiple clients at the same time to improve data throughput and reliability. That function is not available on the early ones. So it is key to find out whether or not it does support the OFDMA functionality, especially if you're looking for high density network solutions. So that really covers what the benefits are, what some of the limitations are on Wi-Fi as a whole. Hopefully it's clear as to where these will fit into your solutions. So just to have another look at the AP overview. So I quite like this screen because it shows you physically where they sit in terms of low end and high end for the actual portfolio. And obviously the price would also reflect that. So you'll start off with the 1123AX, then the AX Plus, then you go up to the WAX series, the 510D, the 610D, then the 650S, and you can see at the bottom it shows you the specifications for whether it be a 2x2 antenna, a 4x4 antenna, and you can see the 11,000 series, so the 1123AX is Nebula Flex enabled, but the WAX actually in Nebula Flex Pro. So you'll get some licensing bundled in with that as well when you buy it. So that's worth noting as well. So in regards to switching, at the moment, we've got the XS3800-28 available. So this is a multi-gig switch. So this has got 4 multi-gig ports on it, which can do 1 gig, 2.5, and 5 gig on Cat5e cable. And on Cat6 and Cat7, it could actually do all of the above and up to 10 gig as well. So these sort of switches are really good for you to be able to boost up your network from a gig network to a 10 gig network without having to recable it and put fiber everywhere and things like that. And these are also stackable as well, so you can stack them and make them into there'll be like multiple physical switches, but it'll form one logical switch. So coming in April, now I say April very loosely because as I've mentioned, with everything that's going on in the world at the moment, logistical issues are being raised and not being able to get equipment as quickly as what we have been previously. So I'm saying April at the minute, but it could be towards the end of April, sort of May time, that these could come out. So the XS 1930-10 and then 1930-12 HP. So these are both multi-gig switches, both available on Nebula Flex. The 12 HP will allow you with 8 Ultra PoE ports. So in essence, you'll be able to power 8 AX access points and benefit from the 2.5 gig port and the 5 gig port. And it comes with a nice healthy budget of 240 watts as well. And it's got an internal PSU, so you haven't got any external PSU or any additional cable and anything like that that you need to sort of tidy up in your cabinet. They are going to be necessary for you to implement a full AX solution. At the moment, if you wanted to go for an AX solution, you'll have to look at going for the XS 3800-28, and then you'll have to look at getting like an external PSU for the access point at the moment. The PoE switches were supposed to have already been sort of out, but again, delays have happened, unfortunately, which are outside of our control, but we are anticipating them in very soon. So that really concludes an overview of the WAX access points for today. You'll see on the screen that there is the part code there. So if you wanted to speak to distribution about pricing or look at actually purchasing one, then give them a shout. give them that part code, and then they'll be able to do that for you. So there is a questions section at the moment. So if you do have any questions, just feel free to post them, and I'll keep the webinar open for another minute or so just to try and generate some. So thank you very much. Okay, so there don't seem to be any questions coming through. So either you understood everything that you've been told, or you haven't generated any sort of questions based on what I've discussed. Again, I'm always here if you need any assistance, any advice, then feel free to get in contact with the office. Again, my name's Daniel Marsh. I am one of the UK sales engineers, so I do come from a technical background. I've also got my colleague as well, who's Nigel Canning. He looks after the southern area and is also a sales engineer, and again from a technical background, and has quite a lot of experience in hospitality as well. So I'd like to thank you all for joining me on today's webinar, and if you keep an eye out on our mail shots, you'll see that we do have some further upcoming webinars as well. So thank you again for joining us, and have a good rest of your day. Thank you very much.